Yeah, is my voice audible to everyone? Thank you. I'm just sharing the content with you. Yes. Now we'll start with the geometry part. We did algebra. We did, in the previous sessions. So in algebra, yeah, I remembered one thing. It reminds me one thing because we did algebra, and the last question we were doing something parallel lines distance we did, and we were getting a huge number. Okay, you remember that one? I remembered that day. Okay, so I was getting from something around 25 by 2. Hope you remember that one. What I was taking, the mistake is C1 into C2 I was taking, it was C1 minus C2. Please note down if, yeah, if you have noted it wrong, distance between two parallel lines in a coordinate geometry is this one, C1 minus C2. I was taking C1 into C2, and I was looking at the denominator, where was I going wrong in the denominator? It was not the denominator, it was numerator which was the mistake. Clear? Okay. So we'll start with geometry. Important one. Definite questions from geometry in any exam you take, any MBA entrance exams you take. And usually people feel geometry very difficult. It is not difficult at all. It is not difficult. It is more of remembering facts. A lot of people feel difficult because a lot of facts has to be known in this. Clear? Lot of theorems, lot of axioms, lot of rules are there in this. Clear? Those rules, if you know, if it is on your fingertip, then it's very easy. Okay, you have to just play with those rules to solve the problem. If that is known, the rules is known, then it's very, very easy. Clear this one? What are these rules? That is what we are going to see, and how do we apply this one is very, we will see here. Okay, so a lot of rules are there, as I told you. We'll definitely discuss all rules. A lot of problems will be homework for you. You have to solve that because I told you, once you know the rules perfectly, solving is very easy. Clear? When people say it is difficult, geometry is difficult, that means they don't understand all the rules. Algebra and other things like permutation combinations, it is not like that. Even if you know the rule, how do you apply it in the question? That is a difficult part. Yes or no? How do you solve the question? That is also another difficult part. How do you form an equation? It is a difficult part, isn't it? Geometry is not like that. You visualize the figure, you apply the rules over. Only that applying which rule to be applied and what rule to be brought, that is what you have to see here. Okay, yeah, I'm starting from basics. That's why I'm going very slow. Here, I'll look at this one. I'll go very slow, and 25 problems are given there. All are very important. You have to solve all the problems, even though if I leave it. Clear? Few problems which you can solve, I will leave it. A few problems, easy problems, you will solve. Okay. So based on that, first, the basic rule in geometry I'm telling you. First, get perfect in the rules. That is the only tip I'll give if you want to improve in geometry. Nothing else. There is only one important tip. By heart rules or understand the rules, it has to be in your fingertips. Once if it is there, it is done. Clear? Any figure is given, you can solve it. So let us solve it. I think you understood what I'm trying to say. For example, in algebra and other chapters, you will see that they'll give a statement. You have to understand what is it. Okay, you have to visualize it. You have to see how to form an equation. After that, solving. After that, getting an answer. Geometry is not like that. Yeah, correct. Chidrubi, I'll say formulas. Anyway, formulas are there. Geometry is completely of formulas only, isn't it? In geometry, rules you have to remember. Rules are nothing but, they form the formulas. You remember that formulas, just apply it. Clear? Application it will become very easy in geometry. Okay, only remembering the rules you have to see. First, very basic thing that I'm going to start with. Today, we will discuss lines and properties of triangles. There are circles we discuss. There are mensurations, 3D geometry. That means three-dimensional geometry, cubes, cuboids, cylinders, that also are there. Clear? But today we will focus on very basics of geometry, that is lines. Okay, next is triangles, properties of triangles. Very basic. Without that, you cannot do further geometry. Understood this one? Okay, clear? Now, first of all, you have to know what is difference between, a lot of people know it, but A lot of people are not from maths background. For them, I'm revising. You learned already in schools. For them, I'm revising it again. Okay. What do you mean by line segment? Line segment. Clear? From there, I'm starting. You understand this? It's from very basics. I'm starting from very basic definition. I'm starting. Okay. Line segment, line, and a ray. Just a minute. And ray. There are three things. What are differences between them? Okay. Now, what do you mean by line segment? Line segments has an endpoints. There are endpoints for, yeah, correct. Two endpoints are there. It is called a line segment. What is a line? Line is actually, this goes to infinity, this also goes to infinity. There is no endpoint to it. It is going this way, infinity. This way, it is also going to infinity. Okay, so there is no end. There is no stop for it. Ray. Ray, one end is there, the other end is infinity. Correct. Very good, Arshad. One end point is there, our starting point is there. The other point is infinity. Clear? Three lines, if they join, they form a triangle. But look at this one, A, B, C. A, B, C. These are line segments. What are these? These are line segments. AB is a line segment, AC is a line segment, BC is a line segment. Clear? Because in line segment, a line can be given a boundary to it, given two endpoints, it becomes a line segment. Clear? Ray is this one. This is ray. Clear? If one line is there, I cut that line with another line. Okay. If this is point A is origin. From there, there is four rays that are okay. From there, it is originating. Four rays that are originating. So this is line segment, line, and ray. Clear? This everybody knows. Clear? Now, what do you mean by parallel lines? Parallel lines means two lines when they don't meet at any point, in any given point, infinity points you also give, if they don't meet or they don't intersect, they are called parallel lines. They are called parallel lines because they will never, you extend this line here, this line here, this line here, and this line here, they'll never meet. So they are parallel lines. Clear? There is something called transversal. Transversal is something which cuts these lines, intersect these lines. Is called a transversal. It's called a transversal. Clear? This you saw in schools only. In 8th class, you will be introduced to this geometry. Okay. Next one. You understood line segment, ray, parallel lines, and a transversal. Okay. This is a transversal. This A is a transversal, where B and C are parallel lines. Clear? Okay. Now we'll come to this back again to this parallel line and transversals. Again, we'll come back to this. Okay. Now, the properties of this one are very important. Okay. The next important thing in this is triangle is where three lines can form a triangle. You require how many? Three lines. With two lines, can you form a triangle? Not possible because triangle itself is three lines, isn't it? That is obvious. Clear? Quadrilateral. Quadrilateral again, four lines. Closed figure as a quadrilateral. In quadrilateral, there are different, if all sides are equal, we call it square. Okay. Two opposite sides are parallel or 90 degrees, it is making, we call it rectangle. Clear? If it is not making 90 degrees, it is only two sides are opposite and they are parallel. Opposite sides are parallel, we call it parallelogram. If diagonals are perpendicular, we call it rhombus. We'll come to that one. All those things, all those properties we will see. Clear? Okay. So quadrilateral requires four lines. Pentagon requires five lines. Yes or no? These are obvious things. Clear? Like that, for a line, if you want a unique line, if I give a 1 point on the space, I can draw infinity lines. Yes or no? 1, 2, 3, 4, 5 infinity lines I can draw. Clear? But if 2 points are given to me, if they ask me how many lines are passing through these 2 points, there is only one unique line that will pass through 2 points. By this, I can also say that means if you give me two lines, if you give me 2 points, it is enough for me to find out a line. It is enough for me to find out 2 points in that line. If I find out 2 points in that line, I can draw a line. Did you understand this one? Okay. You don't require 3 or 4 points, then okay, this is the line. That is not necessary. 2 points is enough to find out a line. Clear? Same way, 3 points are enough to draw a circle. 3 non-collinear points. What do you mean by non-collinear points? Or what do you mean by collinear points? Collinear points means which are on line, which are on single line. Clear? Okay. Non-collinear means which are not on single line. Okay. They are randomly placed in the space. Okay. 3 non-collinear points if you give, I can draw a circle. That circle will be unique. Understood? No other circle I can draw on this 3 points. These basics everybody knows. Isn't it? Clear? Okay. I'm erasing this. Just sorry. Now we will see. Now we will see this parallel lines and transversal. We will focus a little more on this parallel lines and transversal. Now, in schools, you learned that there are angles. There is an angle 1 here. There is an angle 2 here. There is an angle 3, 4, 5, 6. Oh, sorry. Here also angle 7, 8. Don't mind about numbering here. Just look at this. Okay. So these are the angles. Carefully, you listen to this one. These are very, very important. Okay, and few questions can come from this parallel lines and transversal, and it's a very important property, very basic property. If you don't understand this, then other things in geometry you may not understand. Clear? Okay, everything is interrelated in geometry. You understand one theorem, you go to the next theorem, next theorem. All these theorems are interrelated. Clear? So now look at this one. You can see the numbering is also there. If you look at different types of number, there are only two distinct angles. If you look at angles in this parallel lines, there are only two distinct angles. What are those two distinct angles? If, for example, it should be either 60 degrees or some degrees, okay, that means fixed two distinct angles will be there in the given transversal and the parallel lines. Why? Because if you see 1 is equal to 0, angle 1 is equal to angle 4. Angle 1 is equal to angle 4. Clear? In the same way, angle 2 is equal to angle 3. Look at the figure I have drawn there. Angle 2 is equal to angle 3. Same way, angle 5 is equal to angle 7. Angle 6 is equal to angle 8. Is this clear? All these angles are called corresponding angles. All these angles are called what? Corresponding angles. All these angles are called corresponding angles. So corresponding angles are equal. 1 is equal to 4, 2 is equal to 3, 5 is equal to 7, 6 is equal to 8. Clear? Same way, 1 is equal to 7. Clear? 2 is equal to 8. 3 is equal to 6. 4 is equal to 5. These are called opposite angles. These are called opposite angles. These are called opposite angles. Clear this one? Observe that. Observe that. When two lines are given, when two lines are intersecting, always these angles will be opposite angles. Clear? Next. So if you see, if you observe carefully, all these angles are equal. If 1 is equal to 4, 4 is equal to 5, 5 is equal to 7, 7 is equal to 1, 1 again. You understood like this? Clear? So 1, 4, 5, 7 are equal. 1, 4, 5, 7 are equal. Make that observation. Clear this one? Okay. In the same way, 2, 3, 6, 8 are equal. 2, 3, 6, 8 are equal. Clear? Now, what is relation between this angle and this angle? There are two sets of angle you see. With a tick mark I have drawn, tick mark I have marked, those angles are one set. Into I gave, that are one set. Clear? These are supplementary angles. For example, look at 1 and 8. For example, look at 1 and 8. 1 and 8 together, 1 plus 8, angle 1 plus angle 8 together is 180 degrees. Together is 180 degrees. Whenever two angles, if you add and if it is 180 degrees, it is called supplementary angles. It is called supplementary angles. So if I know 1 is 60 degrees, then automatically you will know that 8 is 180 minus 60. You'll understand that 8 is 180 minus 60 because they are supplementary angle. Clear? So it will be 120. sorry, 120. Clear this one? It will be 120. So if 1 is 60 degrees, you can see 4 will also be 60 degrees. Angle 4 will also be 60 degrees. Clear? After that, you will see that where it is. Yeah, here. 5 is also 60 degrees. You will see that 7 is also 60 degrees. Next, if angle 8 is 120 degrees, angle 6, angle 2, angle 3, everything will be 120 degrees. So there are only two distinct angles, either 60 degrees or 120 degrees. There are only two different angles, that is 60 degrees or 120 degrees. So if you find out one, finding out others is very easy. If you find out one angle, finding out other angles are very, very easy. Clear this one? Okay. Now, these are, theorems that you have learned. Okay, what is difference between theorem and an axiom? What is difference between theorem and an axiom? Okay, quickly note this one. Transversal. By the time I erase, quickly note this. What is the difference between theorem and an axiom? Axiom is something, it is a rule. There is nothing to prove. There is nothing to prove about it. Where theorem, you will pick up from the axiom, you will pick the idea from the axiom, and you will try to prove certain results. That is called theorem. Clear? So geometry is completely made up of axioms and theorem, where theorem is again drawn from axioms itself. Clear this one? Okay, so axiom is a rule. Understood? Triangle, internal angles of a triangle, sum of internal angles of a triangle is 180 degrees. It's an axiom. Nothing there to prove. Clear? Two parallel lines will never meet. It's an axiom. There is nothing there to prove. It's a rule. Clear this one? Okay. So it's a result, not formula. Like, yeah, a formula is a very vague word to use. It is actually result that you're trying to prove. Clear? So axiom is something, rules are there that you need not prove it. You'll obviously have to know it. Clear? So such axioms and theorems we'll see a lot. So hope you have noted down this one. Hope you have noted down. Just look at question here. Using that parallel lines, can you solve the first question? I am giving you 1 minute time. It's very easy question. 1 minute time I'll give you. Solve the first question. It's easy. Ashrit and Alekya, I don't think so. Just check once. Correct. Very good. Very good, Chidrupi, Ashrat, Nitish. Just a minute. Look at this. Very easy. I'll prove it in two methods. First one, obviously, since we are discussing your parallel lines and a transversal, I'll first do with that. Using that, I'll do. Look at this carefully. People who have not understood it and people who are solving geometry for the first time. Okay, you can bring figures, whatever possible for you, whatever you think it is useful for this one, you can bring it. That means you can construct a new diagram, but it should not disturb the original question. Clear? Okay, so I'm constructing a parallel line. This blue color one you see, it's a parallel line. That is, that one I'm constructing, which is parallel to MN and LK. Clear? Okay. And he gave KON angle is 100 degrees. When I draw a parallel line, obviously it will bisect. What do you mean by bisect? It will divide the angle into two. So this 100 degrees becomes 50 degrees here. This becomes 50 degrees here. Because it's a parallel line. It is parallel to LK and MN. It is dividing. Clear? What I have to find out? I have to find out angle between angle of MNO. That means this angle I have to find out. Clear? If these two parallel lines, this is a transversal. ON is a transversal. Look at this one. Correct. Very good, Asha. The other alternators, very good. Excellent. Okay. So if this is 50 degrees, look at this. If this is 50 degrees, you are able to see this one. This is 50 degrees. This is a parallel line. MN is a parallel line. ON is a transversal. Okay. If this is a 50 degrees angle, what will this be? Look at the transversal. Look at the transversal. I told you, if 7 is 50 degrees, what is 4? 4 is also same because extend this one here, extend this one here. This also will be 50 degrees. So this one also will be, what did it? ON, MN, O, no? Somewhere at it. Just a minute. I assumed something wrongly. Oh yeah, sorry. Sometimes my drawing itself will deceive. I have to find out MN, O. This is a parallel line I am drawing. Clear? If I draw this parallel line, what will happen? If I draw this parallel line, what will happen? Because these are not equal, that he did not give. So I cannot assume it as a bisector. If it is bisect, for example, these lines are like this. If this is bigger and if it is like this, okay, that time I cannot assume it is bisecting. So that assumption is wrong that I made, bisecting. Because if KO and ON, if he says it is equal, then you can say bisect. And if these angles are equal, you can say it is bisect. But I cannot take bisect there. So what is another way to do? What is another way to do this one? Here, look at this. I can pick up this clue. If this is 55 degrees, if this is 55 degrees, and this is a parallel line, this also will be 55 degrees. Look at this. Yes or no? This also will be 55 degrees. Where is the pen? 55 degrees. This will be what? 45 degrees at it. Is not bisecting. Then it will beat my assumption. My assumption is wrong there. Okay. So this will be 45 because it's a parallel line. So this also. Okay. Clear this one? To draw it, to extend it. Look at this. This is one line, parallel line. These are, this is 55 degrees, corresponding angle, this will be 55. This will be clear. Okay. Another method. Another method of doing this one is like this. Again, I'm drawing it here. There it's not that clear. Look at this. 1, 2. I have to find out this. He said this is 55. Okay. Yeah, with the triangle I'm proving it. Now I'm with triangle I'm proving it. This is 100 degrees. Clear? Now extend a line. This is a triangle. Okay. That means here I'm extending a line. This line I'm extending. This line I'm extending. Okay. So now let me erase all of the things. I only know this much information. I only know this much information. If you see, this is an external. This is an external line. This complete thing, this whole thing is 180 degrees. This whole thing is 180 degrees. Yes or no? If this is already 100, how much this will be? This will be 80 degrees. Yes or no? Because it's a line, it will be 80 degrees. Clear? Okay, and it is a parallel line. If this is 55 degrees, if this is 55 degrees, how much this will be? How much that will be? 55 degrees. Because this is a parallel line, this is a parallel line, this is a transversal. Okay, I'm writing it here. It is AB. This is a transversal. Clear? 55 degrees. So internal angle of a triangle is 180. So I'll add 80 plus 55. Okay, and I have to subtract this from 180. How much is that? 80 plus 55 is 135. 180 minus 135 is clear. Either way you can do. Only you have to visualize in geometry. Just you have to get the right figure, visualize it, apply the rules. You'll get the answer. Okay. Please note on this. Either triangle method or this method. Or this method. Either you can take a parallel line. Here bisecting is wrong because KO and ON is not equal. Okay. So you should not assume it is bisecting. Next. Second question, 1 minute time. Second question, 1 minute time. You just draw the figure, you'll get the answer. No, no, Ashit. Not sorry, Arjun. Ashit, again check your answer. No, no, no. I did not get right answer. Anyway, good try. Let's see what is the answer. I got one answer. Let's see whether it's correct or not. Okay. AB and CD are two parallel line segments. AB and CD are two parallel line segments. Okay, I'm drawing it here. They are two parallel. A, B. Here it is C, B. Two parallel line segments. Okay. E is a point between them such that EAB is 60 degrees and ECB is EAB. There is a point here EAB is 60 degrees. That means this one is 60 degrees. Okay, ECB is how much? How much did he say? ECB is 70 degrees. That means they are not definitely equal. Okay, 70 degrees. Okay, next. What is the measure of AEC if A and C? What is the measure of AEC? He is asking AEC. What is the measure of angle AEC if A and C lie on the same side of E? That means this side only. That already we took. This side only it's lying. He is asking us to find out this. He's asking us to find out this. The complete one, not the half of the thing, the complete one. So again, I'll do the same thing. I'll draw a parallel line because I know the properties of a two parallel lines and transversal. Clear? Okay. If this is 70, if this is 70, obviously this is 70 degrees. Because 70 here corresponding angle will be 70, opposite of corresponding angle will be equal, that is 70. Here also, if this is 60, AB is a parallel line with E, so this will also be 60. 60 plus 70 is equal to 130. That's it. Very easy question. Okay. Any doubt here? Nobody answered it right. Please just check because he's asking angle AEC. He's asking measure for angle AEC. Can't use triangle here. If you want to use triangle, let us check. Let us check. Arjun is asking. So let's see. AE. E. There's a triangle. Okay. Clear? Now, if this is 60 degrees, if this is 60 degrees, and you draw a parallel line to this one, You draw a perpendicular line. You will assume that it is a perpendicular line. What will this be? This will be 30. That is what you will take. And you will say this is 70. So this will be 20. Okay. So 180 degrees minus 50 is how much? 130. That's clear. Okay. You can do it. There are other ways also. You can draw figures. If you know more rules, more type of figures you can get, and you can do it. Next one. Next one. I'll give you 2 minutes time for this. Again, same parallel lines and transversal you have to apply. First five problems you have to do say same thing. Parallel lines and transversal. So third one also, I'll give you 2 minutes time. Please solve this. Group B says B. B means how much? 125. Krishna says C. He said A, I, B, K are also coming. What is he asking? A, B, D is asking. Okay, I got different answers. Slowly, carefully apply it. Do not take anything that is extra. You will go wrong. Triangle you can apply. Triangle. Some of the internal angles of a triangle 180 degrees you can apply here. Look at this. This one is also easy, but it takes a little long. That's all. Nothing else. Carefully you have to do HJI. This is 60 degrees. This one is 60 degrees. Okay. After that JHI. This is 55 degrees. Clear. Okay. After that, he is asking us to find out A, B, D. This angle is asking us to find A, B, D. Clear. We have J. We have H. Can't we find out angle at I in this triangle? So total is 60 plus 55. 60 plus 55 is how much? It is 115. Isn't it? Clear? From 115, from 180, I have to remove 115. Are you understanding this one? So that is how much? 65 degrees. Clear? So this is 65 degrees. If this is 65 degrees, if this is 65 degrees, obviously this will be 65 degrees. Or you can go here also directly. If you don't like this one, you can go here also directly. This is also be 65 degrees. Your wish. Now, if this is 65 degrees, if this is 65 degrees, this will also be 65 degrees. Or from here, you can come here. Okay. If this ultimately will come here, now 180 minus total is 180. Now, from here to here, the total is 180. Look at this one. This I got 65 degrees. So 180 minus 65 is very good. That's all. Very good, Krishna Ashrat. Others, please check. If you're still not able to agree it, then you can ask. Not a problem. Fine. See, I have to find out angle at I. From there, you take this side corresponding angle or upside corresponding angle. Anything is same. Clear? So note it down. By that time, I'll erase this. Oh, no need to erase. Let us go for the next one. Yeah, you're asking some doubt. You're asking nothing. Fourth one. Again, 1 minute time. This is very easy one. 1 minute time. That's all. Fourth one is A. Let's check. Now, fourth one. What is the value of angle AED in the figure given below? Okay. So now, what is the value of AED? He said AED. I have to find out this. Clear? In the figure given below, and DE and AE are the bisectors of ADC. He's saying DE, this one and this one bisectors. That means if this is X, this also will be X. Clear this one? Okay. Now, after that D and A, now ADC, where is ADC? ADC is this. EAB is this. This is bisectors. There's also our angular bisectors. Okay, that's all you get. AB is parallel to CD. AB is parallel to CD. That's all he has given. Clear? Now, why do this 120 degrees required for us? He's just confusing it. This is not required at all. This 120 degrees is not required. Please note it down. Without that, I can do this. How should I do it? Without that, also I can do it. How should I do it? How would I do it? I don't want that 120 degrees at all. It's not useful at all. But there is one important property that I can use and find out quickly with that. Bisects means, yeah, making it half. Very good. So I'll write it down for you. This is why, that this also is why. Very good. So what do I get from this? What do I get from this? You're understanding without that 120 degrees. What usually people will do, since these are parallel lines, if this is 120 degrees, this will be 180 minus 120 degrees, so they'll take 60 degrees. No use of that. No use of that. Okay. You understand one thing, these are parallel lines. Same logic I'll apply here. That means 2y plus 2x. Understand, this complete angle is 2y. This complete angle is 2x. Should be 180 degrees. Should be 180 degrees. I'm not able to write here. I'm writing it here. 180 degrees. Clear? Why? Look at the parallel lines in the transversal. If this is one angle, corresponding to that angle will be here, somewhere here. So this one will be supplementary. So it will be 180 degrees. So y plus x is equal to 90 degrees. If both are 90 degrees, obviously E will be what? 90 degrees. Answer is D. Alekia, check your answer. Any doubt, please ask. Others, 2x and 2y is equal to 180 degrees, x plus y. Yeah, correct, perpendicular. Okay, so x plus y is 90 degrees, then E will be 90 degrees. Is that fine? Alekia, Ashrit, and Chidrubi? Okay, great. Next one. Fifth one, take 2 minutes time. Take 2 minutes time. In geometry, a lot of redundancies you get. You can just remove, ignore those redundancies if it's not useful for you. Take time, but I need answers. I need answer for this. Chidrubi, Krishna, both are saying B and B. B, let me check quickly. Let me check. No, 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 no. I don't think so. B. You have to just check. I don't think so. B, because B becomes very small. B becomes very small. Very good, very good. Arjun, Alekia, and Amit. Very good. You got the answer. Look at this one. Very easy again. I'll draw a parallel line. I'll draw a parallel line. If this is again, see, let us call this line as E. Okay. This line and AB are parallel, and this line AE is transversal. If this is 35 degrees, this will be 35 degrees. If this is 35 degrees, this will be how much? 25 degrees. Clear this one? Okay. Understood. So what I can do with this? If this is 25 degrees, what is next thing I can do? Again, parallel lines will apply. E is parallel to DC also. If this is 25 degrees, this will be 25 degrees. Okay. In the triangle, total should be 180. In that, I'll remove 25 plus 10, that is 35. I'll remove. So I'll get 145 degrees. Is this clear to everyone? Chidrubi? First consider parallel line AB and E. Next consider parallel line E and DC. Yeah, okay. I'll draw a parallel line on E. So I'm taking this line as E. Now AB and E are parallel. AB and E are parallel. So if this is 35 degrees, this also will be 35 degrees. Clear this one? This also will be 35 degrees. Isn't it? Okay. Now if this is 35 degrees, okay, after that what we will do, we will alternate angle. This is an alternate angle, 35 degrees. So totally 60. 35 plus 60. Yeah, correct. 25. So again here alternate angle, 25 degrees. That's it. Very good. Now this is about parallel lines and transversal. Only concept of parallel lines and transversal. Then question is very easy. Okay, but it is not always like that. They'll also ask you to apply triangles also. Here, one important thing that you have to remember in triangle, I told you internal angles of a triangle are 180 degrees. That is an axiom. Another axiom, very, very important axiom. Very important axiom, not only in geometry, you usually apply in other chapters also. That third side should be always less than sum of two other sides. Everybody knows this one, no? For example, if this is A, this is B, this is C. Always remember that C is less than A plus B. A should be less than B plus C. That is a rule, or else you cannot form a triangle. B is less than A plus C. That means the third side is always less than sum of other two sides. That is a rule. That is an axiom that everybody has to know. Clear? Not only that one, difference of two sides is always less than third side. For example, A minus B. This is two sides difference. This will be always less than third side. C minus A. This will be always less than B. Next is A minus C, C minus B, B minus C is always less than third side. Okay. That means I can write combinedly that A minus B is less than C minus B less than A plus B. Remember this one. All these are important. This one is important. Please note it down. And everybody knows this one, or else I cannot form a triangle. Obviously, look at this one. For example, C is very huge. It is greater than A plus B, and A and B are only this much. How can I form a triangle? C is this much. Can I bring them together and form a triangle? No. So that's why he's saying A plus B should be always greater than C. If it is equal, then A plus B equal means one parallel lines will come. This both are together is A plus B. Parallel line will come. That is obvious. Okay. So note it. Using that you can do 6 and 7, but 7th I am leaving it as an homework because other things also we have to do. 6th question you can do. I'll show you 6th question. Easy. They are not very difficult. You need not do anything on the paper. One single step over answer. 6th one answer. No, Arjun. Alekya, look at this carefully. I'm showing you once again this one. Look at this for 5 seconds and understand what he's trying to ask them. Okay. Third side will be less than some of them, and difference of them will be less than the third side. Now think properly. Just by thinking, you'll get the answer easily. 6th one. Oh, okay. I'll do it. See here. He gave two sides as 5 and 8. Isn't it? Third side we don't know. He gave two sides as 5 and 8. 5 and 8. Third side we don't know. Let us take it as C. Let us take it as C. We know for the fact that C, 5 minus 8, that is difference of 8 and 5 is 3, is less than C, less than 5 plus 8, that is 13. This much you know. From here I took this. Isn't it clear? But what do you mean by perimeter? Perimeter means outer region. Complete length is perimeter. That means sum of all sides of a triangle. Sum of all sides of a triangle is A plus B plus C. Clear? In this one I have A plus B. What I'll do, I'll add C. Sorry, I'll add 13 to everything. I'll add 13 to this one. It will become 16. I'll add 13 to this one. Why 13? 13 is sum of two sides. Third side also I'll add, it will become perimeter. I'm adding 13 to this C, so it will become perimeter. Less than 13 plus 13, 26. That's it. This is the range of perimeter. This is the range of perimeter. Okay. So do we have option for that? Yeah. Option D. Okay. So look at this. Look at this. For 10 seconds. We'll do other questions. I'll go for the other questions. Seventh one again. It's an homework. Think carefully and tell me the answer for seventh question tomorrow. Not today. I need not do today. Just look at this one. What it is. Okay. Now, properties of triangles we are going to see. Now you'll see properties, properties, properties. Slowly I'll go because a lot of non-maths background students are there. We'll start with very basics. You already saw some of the angles of a triangle is 180 degrees. Third side is always less than sum of two other sides. A difference of two other sides is less than third side. That you saw. These are the two triangular properties that we have learned. More properties you will learn. First of all, you have to understand there are different types of triangles. When all sides of a triangle are equal, when all sides of a triangle are equal, that is A, it is called an equilateral triangle, isn't it? It is called an equilateral triangle. Sorry, what did I write here? A. Yeah. Sometimes I do like that. Thanks, Ashton. Next one. When two sides are equal and third side need not be equal, then it is called isosceles. Okay, clear? Next. In isosceles triangle, two sides are equal, third side need not be equal, isn't it? Clear? Now, right angle triangle means one side will be, so one angle will be 90 degrees. This is a right angle triangle. What triangle it is? A right angle triangle. Where all sides are different, it is called scale-in triangle. It is called scale-in triangle. Clear? After that, if all angles of a triangle, internal angles of a triangle is less than 90 degrees, if it is less than 90 degrees, all angles of a triangle, if it is less than 90 degrees, it is called acute angle triangle. What it is called? It is called acute angle triangle. All angles of a triangle are less than 90 degrees. It is called, whatever it is, acute angle triangle. Next, if all angles are greater than 90 degrees, if all angles are greater than 90 degrees, it is called obtuse angle triangle. Usually acute means acute angle, the meaning of acute angle itself is less than 90 degrees. Not all. Now in acute angle triangle, one of the angle is greater than 90 degrees. Sorry, not all angles. How can all angles be greater than 90 degrees? Obviously it cannot be. Yes or no? If one of the angle is greater than 90 degrees, if one of the angle is greater than 90 degrees, clear? Then it is called obtuse angle triangle. Then it is called obtuse angle triangle. Something like this. This is a larger one. Okay, something like this. Okay, clear? Next. Complementary angles. You have seen supplementary angles where x plus y, two angles x and y. If you add them and they become 180 degrees, they are called supplementary. They are called supplementary. If two angles I add and they become 90 degrees, then they are called complementary. Very good, Alekia. They are called complementary angles. Understood? When two angles I add and if it is 360 degrees, it is called they are called reflex angles. They are called reflex angles. Clear this one? First one, all sides are equal, equilateral. Two sides are equal, isosceles. No side is equal, it is scalar. One angle is 90 degrees, right angle triangle. All angles are less than 90 degrees, acute angle triangle. One angle greater than 90 degrees, it is obtuse angle triangle. Clear? Understood? In equilateral triangle, since all sides are equal, you know all angles are also equal. All angles are equal means if three angles are there, 180 divided by 3 is 60 degrees. That means all angles has to be 60 degrees. That is what equilateral triangle says. Has to be 60 degrees, not less, not more. Clear? Isosceles triangle. Isosceles triangle corresponding angles are equal. These corresponding sides of an angles are equal. That means these angles, this x and x are equal. This will not be equal. That is an isosceles triangle because these sides are equal. Clear? Right angle triangle, you know, one is 90 degrees, other will be sum of 90 degrees. Scale and triangle, all angles are different. Is this clear? Up to here, is this fine? This everybody knows, isn't it? The namings, these are the namings of the triangles. Now let us look at area of a triangle. Let us look at area of a triangle. Area of a triangle, if I ask anybody, they'll straight away say it is half base into height. Okay, what do you mean by base? Let us take a triangle like this. Let us take a triangle like this. This is the base. This is A, B, C. This is the base. And if I drop an altitude which is 90 degrees, if I drop an altitude which is 90 degrees, this is called height. Clear this one? If I know the base and height, I can easily find out any triangle area. If I don't know the height, I know only the sides of the triangle. If I know only the sides of the triangle, sorry, what about this? Yeah, the formula is this: S into S minus A into S minus B into S minus C. Clear? Understood? So what is S? S is semi-perimeter. Semi-perimeter means A plus B plus C. All sides of triangle divided by 2. That is what semi-perimeter is. Okay? Under root S into S minus A into S minus B into S minus C. If I know all the sides of the triangle. If you don't know all the sides of the triangle, if you know only the base and the height, then half BH. Then half BH. Clear? Okay. Where did I actually get this half BH from? Because you know, if this is a rectangle, this is the base and this is the height. Okay. If I draw a triangle like this, two triangles, what is the area of the rectangle? Rectangle is base into height, but half of it is triangle. The triangle is only this much, no? The triangle is only this much, so it is half BH. That is where we got this area formula: half into base into height. Clear? Okay. Now for an equilateral triangle, do we have a separate formula or should we have a height compulsory? You don't require a height for this one. Quickly, I'll prove the area of a triangle. Just look at that. If you know the trigonometry added advantage, but it's not necessary. Without that also you can solve. Here, you know that triangle is 60 degrees. Equilateral triangle has angle 60 degrees. Let us say this is the height. Okay, so this is the base. Understood? Can you quickly tell me which trigonometry ratio is opposite side by hypotenuse? Opposite side by hypotenuse. Can you quickly tell me which trigonometry ratio says opposite side by hypotenuse? Sine. Very good. Isn't it? So let us say this height is h, hypotenuse is something like x will take. X. So sine 60 is nothing but h into h divided by x. That is what trigonometry ratio tells us. What is sine 60? Here the angle is 60 degrees. What is sine 60? Sine 0 is 0. Sine 30, 1 by 2. Sine 45, you learned that one. Yes or no, 1 by root 2. After that, sine 60 is how much? Root 3 by 2. No, like, yeah, tan is opposite side by adjacent side. Sine is opposite side by hypotenuse. Okay. So it is root 3 by 2 is equal to h by x. Clear? That means h is equal to how much? Root 3 by 2 into x. From here, I'll put this one into this formula. Okay, since it's an equilateral triangle, if this is x, this base also will be x, this also will be x. So half Base is nothing but x. Height is nothing but root 3 by 2. That is nothing but root 3 by 4. Equilateral triangle. That's all. If I have a side of an equilateral triangle, it is very, very easy for me to find out with formula, that is root 3 by 4 a square. This is what you see in books. Root 3 by 4 a square. Is this clear? Okay. Now, what if it is not an equilateral triangle, but still I want to find out with a trigonometric ratio? Remove this, take this one as theta. It is not an equilateral triangle. If this is theta, same thing. This becomes sine theta is equal to h by some x here. This will be base as it is. I'm erasing it. Do not get confused. Now, equilateral triangle I proved already. I am taking now for non-equilateral triangles. Okay, I'm finding out a general formula for it. Okay, so h is equal to sine theta x. Sine theta x. H is equal to sine theta x. So this I'll put in this. This I'll put. So it will become half base into sine theta x. Now you'll ask me what good this will do to us. Please note it's a very, very important formula from CAT perspective. Why? Because if I have a triangle, look at this one. If I have a triangle A, B, C, and if I know only one angle, I can directly put it this like this. Half into this A and B is there. In between them, theta is there. That's all over. You can apply this formula. Understand this one. Theta has to be between these sides. So it is half A into B into sine theta. Remember this one. You will see the applications of this one. Take 1 minute time. Please carefully one by one note it down. Understood? In geometry, more than questions, please focus on the formulas and the concepts. How did I develop those formulas? Please note it down. First one is half BH. That is one type of, everything is an area of triangle only I'm discussing here. Clear? Next is scalar triangle. That means, sorry, if you don't know height, what you have to do. Semi-perimeter, you can find it out. Yeah, this is for area. Okay. Equilateral triangle area, I've just proved it. Root 3 by 4 a square, because a is equal, all sides are equal. So single side is a, each and every side will be a. So this half AB into sine theta is also, instead of using BH, if you don't know height, you can do this one, because always you will not know height. Height is something which is not given in the question. Triangle dimensions they'll give you. Height is, they'll not mention it always. So that time we can apply this formula, half into A into B into sine theta. Okay, clear? Next. So one more, one more thing you have to observe in this area. If you take a right angle triangle, ABC, you know that base is BC. What is base? Base is BC. You know that height is equal to AB. Clear? If you apply in that half, I said A into B into C sine theta, A into, this is A and this is B. A into B into sine theta. Sine theta is what? Sine 90 is what? Sine 90 is 1. That is nothing but half into base into height. Because AB is nothing but height. Sine 90. You can observe that one if you want. Sine 90 degrees. Clear? And you also know in right angle triangle, you can apply Pythagoras theorem. A and B, the third side is A square plus B square. Clear this one? Okay. In triangle, these are internal angles. If this is A, the external angle, if I extend this line, it will become 180 minus A. That everybody knows because it's a line. In a line, it will always be 180 degrees. In that, one will be A, another will be 180 minus A. That is obvious. So if you know this is as B, this will be 180 minus B. Okay, like that for this also you can do same thing. 180 minus B. Like that if this is C, 180 minus C. This is obvious, no? I need not tell you. This is clear. Okay. Next one. Okay, areas clear. Now one more thing. You have to understand. Should I go for the problems? Okay. Let me do this. I told you about altitude, isn't it? Just now I told you altitude means when I drop a 90 degrees. This is A, if this is B, if this is C. Okay. If I drop a 90 degrees from one of the vertices, that is the height. Again, I'm repeating. If I drop perpendicular line from a vertices onto the opposite line, it is called height. Okay, height of the triangle. Okay, 90 degrees, definitely 90 degrees it has to be. It has to be from a vertices. It has to be from a vertex. Clear? Okay, so this is height. This is called altitude. Like that, I can drop and I can take an altitude from B to onto AC. I can take an altitude from C to AB. All these three altitudes will meet at a point. All these three altitudes will meet at a point. What is that point called? What is that point called? That point, can any guesses? Very easy. You learned this one in schools also. Like that, you will see several centers we will see now. Not centroid. It is called orthocenter. What it is called? Orthocenter. It is called orthocenter. Clear? Did everybody understood this? It is called orthocenter. Next, slowly I'm going. A, B, C. Okay, when A, B, C are there, when I draw a line, which will bisect this BC. Bisect means which will make BC into two equal parts. Bisect this BC. Okay, that line is called median. What is that line called? Median. What is that line called? Median. If three medians I draw from different vertex, meeting point is called centroid. The meeting point is called centroid. No, not Aleke, not in center, centroid. Okay, what Krishna said is here. This one, meeting point. Orthocenter means line, sorry, heights meeting point. Centroid means median's meeting point. Clear? Okay, next one. There is something called line bisectors. Line bisectors will not start from vertices. It can start from anywhere, but it has to be particular. It has to be perpendicular, and it has to divide the line into two equal halves. Clear? It has to divide the line into two equal halves, and it has to be perpendicular, and it need not start from vertices. Don't get confused with altitude and this one. This is a line bisector, and do not get confused with median also. Very good, Krishna. Okay, so I can draw line bisectors for all the three lines. Line bisectors for all the three lines. Clear? Line bisectors, all the three lines will meet at a point that is called, rightly said, Krishna rightly said, it is circumcenter. What it is? Circumcenter. Why do we call it a circumcenter? Why? Because if you take that center, and in geometry box, we used to have a compass. You take that one and draw a line, you will get a circumcircle which will pass through vertices. You will get a circumcircle. Okay. Let us take this point as E, the center, that circumcenter as E. You know that AE is equal to AE, line from AE is equal to BE is equal to C. Is equal to C. Okay. That is nothing but radius of the circle. Capital R, radius of the circumcircle. It is called circumradius. It is called circumradius of the triangle. It is called what? Circumradius. So circumcenter, circumcircle, circumradius. Circumradius, how do I get? Line bisector. Next is angular bisector. Next is angular bisector. That means if one angle is here, if I bisect this, that means I'm making these angles into two halves. Two equal halves. Sorry, not two halves, two equal halves. Again, I'm bisecting this line, this angle also into two equal halves. Clear? That meeting point is called in center. Very good. It is called in center. Ortho, centroid, circum, in. Clear? In center. Why? Because why it is called in center? If you keep this as a center and draw a circle, you will get an in circle which will touch the sides. Which will touch the all three sides. Clear this one? Okay. This in center. Sorry. First of all, let me talk about the circle. Clear? This circle will touch again. If I take these points, touching points as let us take D, E, and F. All these touching points are D, E, and F. Okay. And this one has O. That point has O. So DO is equal to EO is equal to FO is equal to small r. That means in radius, not circumradius, in radius. Not the circumradius, you'll get an in radius. Clear? Please quickly note this. Slowly, I'll give you more formulas. Quickly note this. More facts I'll give you. Okay, next one. Done. Next, look at this. Where is the median one? Yeah, median one. Look at this median point. In this median point, the centroid is there. There is a very interesting, uh, fact for the centroid. Can anybody tell me what is that fact? Let us take this one as D. You know that BD is equal to DC because it's a median, it will bisect. Okay. Now let us say this one as O. Okay. Ratio of AO is to OD. Look at that one. Ratio of AO is to OD. AO is to OD will always be 2 is to 1. Very good. Not 1 is to 2, Arshad, 2 is to 1. Because AO will be larger. 2 is to 1. Please note it down. Please note this one also. With the median itself, there is one more interesting one. There is one more interesting. If this is median and this is point D, this is a very, very important fact. This one, which one I'm writing now, is very, very important. It is always like this. AB square plus AC square. AB square plus AC square is equal to 2 into AD square plus BD square. Instead of BD, you can take DC also because BD and DC are same since it is a median. Very, very important one. Please note it down. Very, very important one. Please note it down. I'll wait. Understand it. BD, instead of BD, I can take CD also because BD and CD both are same. Please note it down. AD square plus BD square. Look at this one. True sides of a triangle are there. Okay. That one is equal to base. The perpendicular height and the base squares. Clear? Now, next, after that, I'm erasing this. What is sum of two hypotheses? I didn't understand. I'm erasing this so that there is one fact on. Now I'm writing this. Look at this one. In center, I'm drawing a triangle again. We'll focus on in center. If this is in center, for in center, what is required? Angular bisectors, isn't it? This is an angular bisector. Krishna, I didn't understand. You can reframe it again. Your question. Sorry. Okay, this is an angular bisector. Angular bisector center is what? In center. All three angular bisectors meet it in center. Isn't it? Here, this in center. With this in center, I am writing down here. Okay, if this is a D in center, it's not a median or something. Okay, BD, this one BD. Okay, by DC, EC is this, is equal to AB by AC. Please note down this one also. This is very important. I'm erasing other things. Hope you noted out this important one also. This is also one important one. BD is this, DC is this. That means this by this is equal to this by this. If this is an angular bisector. Okay, next one. Now, one more important thing that I have to tell you. Let me check. Did I miss anything? Now look at this. If this is a triangle, if this is a triangle, clear? If I draw a line, if I draw a line, and if that line, if I draw a parallel length, because parallel to BC, if I draw a line parallel to BC, and this part is X, and this part is Y, and this part will also be X, and this part is Y. Okay, always try to understand this line it will be X, this line at this ratio, this line at this ratio will be X plus 1. Note down this one, X by X plus 1. This line E and BC will be the ratio X by X plus 1. Okay, this is for an equilateral triangle. Again, I'm repeating. If this is X, you obviously know. Look at AC. Look at AC. If I do AC or else I'll do AD by AC. You understand? If I do AD by AC, just observe AD by AC there. AD is nothing but X. AC is how much? X plus 1. Same way, look at AE. AE is X by AB. Is how much? X into X plus 1. Same way. So, ED by BC. ED by BC will be X divided by X plus 1. That is what I was trying to say. Clear this one? Please note on this one. So, from here, you will understand a very important corollary, which will say if a line for an equilateral triangle or an isosceles triangle, if it is half of BC, clear this one? That means this line will cut the triangle also into half. That means this line ED is half of BC, then automatically this also will become half, because here 1 and 1 will become total be half of that one. So this triangle AED will also become half of this one. Will also become half of this one. Did you understand any doubts here? I'm giving you 2 minutes time. Please go through notes that you have written. If you have any doubt in any concept, please ask. I told you now here, rules are very, very important. If you know the rules, application is very easy. Centroid, orthocenter, circumcenter, incircle. Did I miss anything in centroid or in circle? Yeah, one more thing is there in circle. Look at this one. This one also you can note it down. I'll put it in a new board. I'll show you the code. Quickly note down this one also. In circle, there is one more thing which I have to tell you. This is A, this is B, this is C. If this is D, which is an angular bisector, if this is I. Yes or no? I already told you one important one. Where it is it? Where is it? Which I told you A square, AB square, AC square. That I told you for the median, for the other lines. Okay. Look at this one. Look at this one. If this is an in center, angular bisector is this. Uh, it will be AI by ID. AI by ID because it's an in center is equal to AB plus BC. That means the ratio of this one and this one is equal. That is what I am trying to say. Note on this one also. Note on this one also. Take 10 seconds. Please note it. And note on this. AB plus AC. Yes. Oh, sorry. I have written BC. Sorry, sir. Correct. Thanks for correction. I have written BC here. AB plus AC. Note on that. No, make correction. As Krishna said, make that correction. AB plus AC. That means this line plus this line divided by this. Okay, for instance. Any other ratio is there for incentive? Let me think. Am I missing anything? Look at this one. Yeah, one more. This one also. This one is obvious. From here only you get it. PD by DC. PD by DC is equal to AB by AC. Okay. PD by DC is equal to AB by AC. Actually, from here only you can, in derivation, you can see that you can get an info incentive also. Okay, please note on this one. I am missing anything else? There is one more thing that I'll tell you while solving the problem because it's not a formula, but it is the way you solve it. Anything else? Which one? Which one, Alikya? Which one? This is for in center. It is AI by ID. AI by ID is equal to AB plus AC divided by BC. Okay. Same for in center only. You will get BD. If I draw an angular bisector in any triangle, this is in any triangle. BD by DC. This BD by DC is always equal to AB by AC. Oh, you got network. Yeah. This is just for in circle. I'm writing it here. In center. This is for in center. When in center is here, okay. So these are the ratios. I just told the ratios. That's all. Nothing else. I just told the ratios. Okay. After this one I told. This is for an equivalent triangle. This is for an equivalent triangle. Okay, is everybody ready now? There is one more method that I have to teach. After that, one more concept I have to teach. Concept means rules I have to teach. That's all. Over. Triangles and this are very much done. That means there are more, but you will come, in the future. But for now, the areas and this one is over. Similarities and similar triangles and congruences are there. That we'll see later. Now let us solve the questions. Can you solve eighth question? Try. If you are not able to solve it, I'll show how it is. Because you require a method here. If you are able to understand that what method you can apply, but if you're able to understand, it's well and good. If you're not able to understand, I'll do. Please try this. Take 2 minutes time, but answer it. If I tell eighth one, then ninth and tenth also you can do it very easily. Any answers or should I try? Answers difficult. I told in geometry there is nothing difficult. You should just carefully see all the rules. How do you apply those rules? Okay, this is little. Directly you won't get from rules. Answer C. No, I don't think so. Answer C. C. Okay, I'll give a clue. Try this. Okay, I'll give a clue. I'll take another example. One easy example, and I'll show you. Then you try it. Okay. Let us take a triangle like this. A, B, C. Check whether you will get with this or not. Some information with this or not. Okay. I have another triangle, another line, which may not be parallel to AC. Listen to this carefully, please. Everybody, listen to this carefully. Which may not be parallel to AC. I will take it as D and D. Very important property. This one. Okay, you can actually prove this one, but here you can obviously you can understand directly. You need not require any geometry rules also. Okay, let us say if this is 1:3 ratio. I'm just taking an example, random example. 1:3, and this is 1:4 ratio. Okay, and for both the triangles BDE, there are two triangles. What are those two triangles? BAC. Another triangle is BDE. For both of them, what is common? What angle is common? Angle B is common. Look at that. Angle B is common. In such cases, you can do one thing directly. You will understand it. It's not from any rules. You can understand it obvious. You know the triangle. You know the triangle area is half BH. Yes or no? You know the triangle ratio is half BH, and you also know half BH can be written as A into B into sine theta. Clear? Now look at both the triangles. Since theta is equal, both angles are BB. Theta is equal. When I divide both of them, theta will get cancelled because angle is same. Look at this carefully. How I am deriving this same clue you are going to apply it in the eighth question. Sin theta cancel. Clear? Now what is the ratio? Now this is A1 B1, A2 B2. First triangle ratio is what? The first triangle, if it is four parts of A, that means 1 plus 3, 4 parts of A. In the second triangle, it is A2. That means BD. BD is only one part. Did you understand? And this base, this complete BC is 5 because 1 plus 4, 5. Here it will be what? Again, 1. Did you understand this logic? Clear? Okay. That means ratio between them is, if this is 20, the above triangle is 20, this will be one part. If the above triangle is 20, this will be one part. With that, I got the ratio of the larger triangle divided by smaller triangle. Larger triangle divided by smaller triangle. Okay. Now again, I'm going to give you 1 minute time. Okay, I'll take this. Take this 10 seconds. You observe this one. If you have doubt, please ask me. Very simple. This one. This is not geometry. Also, you know the ratios are there. I just substituted those ratios. It is not required to know what is the exact length of the sides. If you know the ratios, also you can easily find it. I'll give you 1 minute time. I want correct answers from everybody. Eighth one. I want correct answers from everyone. Amik, I think so. Let's see. You have to apply that one here. How can you apply? Just see that. Any answers? He is asking what? In the below figure, the area of the shaded region is asking. He is asking for BDE. He is asking for BDE. He gave me AC 1 is to 6. Sorry, CD is to AC 1 is to 6. So I'm writing it down for here for you. CD is 1 is to 6. I'm not able to use it. Just I'll draw the triangle again here because I'm not able to use the pen here. So it is ABC, right? A, B, C. Somewhere here E is there. Okay. So he's saying very quickly I'll do. Sorry, not E. This is D. This is D. E is here. E is here. He said AC and CD, AC and AC, CD and AC is 1 is to 6. That means this is one part. Okay, the complete AC is how many parts? 6 parts. That means this is 5 parts. Clear? In the same way, he has given EC BC 1 is to 4. EC BC 1 is to 4. EC BC 1 is to 4. He is asking the shaded part. That means triangle BDE. Okay. If triangle BDE I wanted to find out. If triangle BDE if I wanted to find out. Observe this one carefully. Observe this one, the shaded part. Can I find out the whole triangle and find out the area of BDC? Whole triangle I'll find out BDC. Yes or no? That means what I'm doing, using ABC triangle, I am finding out triangle BDC. Look at this carefully. I am finding out triangle BDC. From triangle BDC, I'll remove the area of triangle EDC. Then I'll get required answer. I'll get the shaded part. So my first task is what? I have to find out triangle BDC. How do I find out triangle BDC? Common angle is C. Common angle is C. I can apply this ratio same like that as it is. Clear? Okay. Now, if this one is 5 by 1, if this is complete 1 is 6, this will be 1. Into this complete thing is 4, this will be 1. Okay. That is nothing but 24 by 1. Clear? So what is the triangle area that they have given? 216. If this is 216, how much this will be? If this is 216, how much this will be? I want quick answers. If this is 216, how much this will be? That means 216 divided by 24. Okay. Is everybody able to understand what I'm trying to say? Clear? Okay. So triangle, what is this triangle area? 9. Complete BDC is 9. So this is 9. Oh, 9. Somewhere I did mistake. Just I'm getting an even lesser one. Okay. So concept is this. Let me do the calculation later. So I'll after that BDC, I'll take EDC. How do I take EDC? Look at this one. EDC I have to take. For EDC again, from BDC and EDC, what is common? E is common. Okay. Now for BDC, what I'll take? BDC, this length is same, so 1 by 1. This length is same. DC length is same. For this one, what it will be? It will be 4 by 1. If this is 4 parts, this is 1 part. If this is 4 parts, this is 1 part. Clear? Okay. Now the calculation part. Somewhere I'm doing the calculation. Did you understand this? Meanwhile, you do it. I just have to check once the derivation. Ninth and 10th, you can do it. With a similar one, ninth and 10th, you can do it. Ninth and 10th is straightforward. They're not asking even the calculation. Apply the same ratios, do it ninth and 10th. I'll give you 2 minutes time, both same questions. Ninth and 10th, at least get an idea. He's asking AOE, BOD. These triangles he's asking. Look at this one in ninth and 10th. Not able to read it. It's become a big problem for me. Again, I have to draw some technical problems. Okay, I'll just orally tell you here. Again, after that, on the board, I'll show you. You're not getting this concept. Just a minute. Just a minute. I'm here. My pen is not working. I don't know what to do. Again, I have to draw all these things. See, I'll draw this ABC. I'll explain again. I'll explain again. Here my pen is not working. It's becoming very difficult for me to see here and there. A, B, C. This one is E. This one is AOD. Clear, sir? Now, the ratios one again we are doing it now. The ratios again we will do using these ratios. He's asking I have to find out ratios of AOE how many times in BOD, or he's asking what is the difference between them. Clear? Okay. Previous one, this concept itself you did not understand. Again, I'll explain it this. Look at this. This is a triangle again. This one you understood or you did not understand only particularly 9th and 10th or 8th, 9th and 10th. You want me to explain from here? This part you want me to explain? Okay. So look at this. This is DE. There are two triangles if you observe. One triangle is BAC. Next triangle is BDE. These are the two triangles. These are the two triangles. Isn't it clear? Common between them is angle B. According to the formula, we know that if this complete length is A, if this complete length is B, if we know two lengths, that is enough. Okay. So it will be half A into B into sine theta. That is what we have noted. Clear this one? Okay. If this complete length is A, this complete length is B. Understood? Now what I'll do is ratio of this one is one part, BE is one part, EC will be three parts. Let us say just as an example. Okay. If BD is one part and DA is four parts. Okay. Total AB is how much? Five parts. Total AB is how much? Five parts. Total BC is how much? Four parts. Okay. So this will be half. ABC, look at ABC, triangle ABC, the bigger triangle will be 5 into 4 into sine theta. If the angle here is theta. Clear? In the same way, another triangle will be the smaller triangle BDE will be half into, okay, half into 1 into 1 into sine theta. Did everybody understand this? Up to here, you understood? Up to here, you understood? So I'll take ratio between them. So I'll get sine theta cancel because both are same, half cancel. So it's enough for me to know. So it's enough for me to know that is 5 into 4 by 1 is equal to 20 parts by 1. Understood? That means the area of the bigger triangle is 20. This will be one part. Clear? That's all the concepts. That's all the whole concept here. Is that fine? Okay. Now I am going to apply it here in eighth question. But this one is somewhere. Okay. Now again from start I'll apply because this drawing is really annoying me. Looking back, looking here, really annoying me. That time, just a minute. I'll do it from first. Now the same thing I'll apply here. Here he has given. If I have a printout, at least it would be great. Now ABC, you can look at this ABC. Let me draw once again. ABC and what ratios he has given? What ratios he has given? Where it is? 1:6. 1:4. Oh, that's a mistake I did. This is 1:6. So this is 5 parts. This is 3 parts. This is E. Clear? What I am doing is asking area of BDE. What is he asking? He's asking triangle BDE. Is this fine? Triangle BDE. I cannot directly find out triangle BDE. So what I'm doing, I know triangle ABC. So from triangle ABC, I'll find out triangle BDC. Look at that figure. Minus I'll do triangle DCE. Okay, now look at this one. In the previous one, I took double time ratio, that is not required. First step is what? I'll find out BDC. From BDC, I'll find out DCE. I'll subtract them from BD. If I subtract this one BCE, I'll get this triangle. Yes or no? Which triangle I'll get? I'll get triangle BDE. Did everybody understand up to here? Did everybody understand up to here? BDE I'll get. Clear? Now, how do I find out triangle BDC? BDC using ratios. What ratio? I'll take triangle ABC divided by triangle BDE. BDC. Very slowly I'm doing, now definitely you will get it. Okay. Now ABC, anyway, you know, half A into B into sine theta. Here is theta, let us say. Okay, with that we are doing. Now let us find out for BDC. ABC, we know it is 216. Okay, understood? From there I am starting. Now BDC, how do I look? How do I look at the ratio of BDC? Now if AC, the complete AC is 6, just DC is 1. Okay, here is a mistake I did last time. The complete BC is 4. This is also 4. In this triangle also BC is there. In this triangle also BC is there. In this triangle also BC is there. So it is 1 by 1. That is a mistake I did. So that means what is the ratio? 6:1 is the ratio. What is the ratio? 6:1. So that means if this is 6 parts, this will be 1 part. Clear? So 216 by 6. How much do I get? I'll get 36. Isn't it? Do everybody agree with me? Yeah. That is where I did mistake. I took here 4 by 1. If you see last time's notes, you know, previous one I did 4 by 1 because BC is same for both the triangles. But still I took 4 by 1. That is a mistake. Okay, please note it down. Now I got 36. This one has 36 I got. Next, DCE I'll find out. DCE. This triangle I'll find out. DCE. For this one, it will be like this. The bigger triangle is 216. Let us find out for the bigger triangle, it is 6. This part will be 1. AC by DC will be 1. AC by DC will be 6 by 1. Next, BC by CE will be 4 by 1. BC by CE will be 4 by 1. Clear? That is nothing but 24. Okay. We wrongly took for this one, BDC. But for DCE, it is 24. The notation was wrong. 216 divided by 24. 6 fours, 636. 4 ones, 9s. Clear? So that means from 36, I have to remove 9. If I remove from 36, 9, what do I get? 27. This is the answer. Okay. 27 is the answer. I am not able to tick it. My pen is not working here. So please note it on this. Where it is? Sorry. 1 minute. Yeah, please note it on this. Did everybody understand this? Now, did you understand the ratio? Ashrit, Alekia? Ashrit and Alekia, did you understand? Yeah. If you don't understand, please, message it like this. I'll be very happy. I'll understand that, where I have to stop and where I have to go slow. Clear? Now, in 9th and 10th question, what you have to do? In 9th and 10th question, what you have to do? Here it is a little complicated, but you'll apply the ratios of sides only. The same thing, ratios of sides. Very slowly, I'm going. Listen to this one. You can solve it in the home. Okay, but listen to this concept. Again, I have to draw this one. That is the biggest headache. Let me draw quickly. ABC. ABC. Don't mind my drawing. Very bad drawing I have. ADBE. Okay. Now, what information he has given? Observe. Look at those questions. He gave CD and BD 4:1. Complete CD and B, that is 4:1. We already gave this thing. Line we got, complete line we got. After that, CE and EC 5:1. 5:1. This much information he gave, and he said, find out. Look at the 9th question. He said, absolute difference between the areas of AOE and BOD. AOE, triangle of AOE minus BOD. Now you'll get stuck here. All of you, please listen to this carefully. It is a little tough to understand. You know, it's a very easy one, but it is, while explaining it, it is very difficult to understand. Okay, understand this slowly. AOE and BOD, I want difference. Can I get directly this one? I cannot get. I cannot get. So there is something common, X and X. I'll add to this one. Okay, I'm adding X and X to this one. Difference of between them is also difference of between triangle AOE and BOD, because X and X will get cancelled. Did you understand? I will add a region X and X to both of them. I take difference of them, that is not, that is again will be equal to, for example, I want difference between A minus B. The same thing as A plus X minus B plus X. There's nothing but A minus B. Yes or no? Then you'll ask, so what, sir? So what should I do here? Why are you saying that? That everybody knows. What you have to do is, you have to find out a region to add to these triangles so that you can find out area of it. Meaning, understand this. What is this X all about? I cannot find out directly from BD and AOE, BOD. What I can do it is I can add a common triangle. Can you suggest me any common triangle? I take difference between both of those triangles, I'll get difference between them. Can you suggest me any such triangle? I'll tell you the triangle name, carefully observe it. If I do triangle, where is this? Yeah, ADC minus BEC, triangle BEC, I'll get this result directly. Why? Because triangle ADC is nothing but triangle AEO plus triangle AEO, this one, triangle AEO plus this region. What is that region? That region is, it is quadrilateral EODC minus triangle BDE, BEC. Triangle BEC is nothing but, clear, triangle BOD plus this is 1. The other region is EODC. Can you find out this? Yes. How can you find out this? Ratios. Look at this triangle. Ratio you already know. One ratio is 1:4. So if I take triangle ABC, the complete AC will be 6. One part will be 5. Clear this one? I am finding out these differences between this one. I am finding out now BEC. I am finding out what? BEC. For BEC, this one. Okay. Next one will be 1:1. Understood? So 6/5 will be the ratio. Next one for ADC, how do you find out? This is for ADC. This is for ADC. ADC. So this will be 1/1. The next one will be, this is 6/5. No? Yeah. 5/4. Okay. So ADC will be 5/4. I have to take difference between them. I'll get this difference. Is everybody understanding? I just gave a clue here. Is everybody understanding here? Can you solve this at home and come? Any doubts? Please tell me. All other questions you can solve. Up to 18th, I can think. Yeah, up to 18th you can think. I think you can solve all questions. Clear this one? Okay. I'll show you also. Okay, all questions you can solve with the facts that I have given: orthocenter, incenter, circumcenter. Congruence and similar triangles I will discuss tomorrow. Once 8th one I have to tell you. You are asking 8th one, Ashit? Eighth question. Okay, look at this. Eighth one again. A, B, C, D, E. Oh, slide I don't have. I have removed it. Okay, just I'll quickly do it. So I took triangle from triangle BDC. I have to remove triangle EEC. Then that will be equal to triangle BDE. Okay. So ABC is nothing but for ABC to be 6 divided by 1. After that, this is for triangle BDC. Okay. That is nothing but 216 by 36. So 36 is the next for triangle DEC. What will I do? I'll get 6 by 1 into is nothing but 216 divided by so 36. Note on this. Tomorrow we'll continue from here. Up to 18th questions you can try, I think. Up to 18th questions you can try without similar triangles and congruence. Similar triangles and congruence, it's a very small concept. It will only take 5 minutes for the explanation. We'll do few important problems and then we'll go to the next one. Okay. Okay. Thank you so much. Any other doubt you want to ask? Please note down this one. I have given you a clue. After that, just check the calculations. The same thing we are going to do. Okay. Thank you so much.